Hi everyone, my name is Min, and I'd like to give you a presentation about how to plot theoretical normal distributions efficiently within R. In data analysis, it's important to know whether your data is normally distributed. So for example, when you do a linear regression, you need to assume that the distribution of the residuals is normally distributed around a mean of 0. And in addition, a number of statistical tests like the student's t-test and the ANOVA also require a normally distributed population. So there are a number of ways of checking for normality of some samples. So one of the ways of doing that is using theoretical normal curves. In this video, we'll be demonstrating how to do that within R using the facet wrap as well as a package called gg4x. I'll now hand over to Carl to go over the data and to show some potential solutions to this.
Hi everyone, so we're going to be taking a quick look at our data here. I'm going to go ahead and load it as well as the tidyverse library that's going to give us access to ggplot and dplyr, and then the car data library, which gives us access to the Titanic survival data set. And this is the data set where we're going to be plotting theoretical normal distribution curves for. A quick view of it here is a list of all the passengers from the Titanic, and we've actually filtered this for those who did not survive. And we're specifically interested in the distribution of ages by passenger class. So we're going to be looking at whether some passenger classes have ages that are more normally distributed than others by plotting the theoretical normal distribution curve for each class. So we're going to have our first strategy for this, which is going to be using ggplot as well as the histogram function, geom density function. That's going to give us our density histogram with a density curve that'll show us the distribution of ages, and then we have the stat function. So this will allow us to get the theoretical normal distribution curve. The two parameters we need to specify are the mean of the ages as well as the standard deviation. And one more function I'm going to call out is this facet wrap on passenger class. This will allow us to get the age density histograms across the three passenger classes side by side. So I just went ahead and ran that, and you can see in blue the density curve for the age distribution in each passenger class, but notice in black, this is our theoretical normal distribution curve. And one of the issues we have is that it's actually the same theoretical normal distribution curve for each passenger class, and that's because we've actually specified the exact same parameter, the same mean and standard deviation across our entire data set is being applied. So we want to show you how to fix this issue. We're going to go over a couple strategies. The first one I'm going to share is just simply subsetting your data into 3 separate data frames for each passenger class. You can see that's what we're doing here for passenger class first. And then we'll have the same set of functions to plot. So same geom histogram density. And then the stat function here is actually going to have the mean and standard deviation of our subsetted data. So once we've done that for all 3, we can go ahead and hit run. And we also have this plot grid function that is going to allow us to get the 3 histograms side by side. And now you can see we've actually resolved the issue we had before. So in these histograms, the theoretical normal distribution curve is specific to each passenger class. So we've fixed the issue. I'm now going to hand it over to Min to show us how we can do this using the library gg4x.
Okay, so now I'd like to show another way of plotting theoretical normal distributions across the 3 passenger classes, in other words, across the 3 different facets. We do that using the package called gg4x. So here I'm loading up the library, gg4x. One change you will see in the code is that rather than using the previous function, which was a stat function, we are using stat theodensity with the aesthetic y as before, calling after stat density. And doing it this way, you will see that the 3 graphs that come out by facet are exactly the same as we got by splitting up the 3 data frames. So the advantage of using this method is that it's succinct, and also there's no need to create additional data frames for each passenger class. So hope this is useful to all of you. Thank you so much.